Hello children and welcome to Top Scholars. In this session we are going to discuss ICSE Board Grade 10 Physics Sample Paper 2025. So let us begin straight away with the MCQs. That is your section A. And here we have the first question in front of us. So the question says, what is produced by two equal and opposite parallel forces not acting along the same line? Please make a note, you'll have four options here. So the first option is translation, second is linear motion, third is couple, and fourth option is circular motion. Let us see the solution. So we know that two equal and opposite parallel forces not acting along the same line form a couple. Also remember, a couple is always needed to produce a rotation. Let us see the second question now. So the question says, the potential energy of a given body depends on configuration, velocity, acceleration due to gravity, mass of the body. Four options are given. Let us see the solution. So the potential energy of a given body depends on the configuration. Please make a note that configuration is the correct answer and potential energy is independent of the velocity, acceleration due to gravity and the mass of the body. Let's have a look at the third question. It says, for loudspeaker in use, the energy conversion takes place. So option A is chemical to heat to mechanical. Option B is mechanical to heat. Option C is sound to electrical. Option D is electrical to sound. Here we are talking about a loudspeaker. So we know that a loudspeaker, when in use, receives electrical energy in the form of electrical signals from the microphone and changes it into the sound energy. So what is the correct option? The correct option is option D, electrical to sound. Let's have a look at the fourth question. It says, which type of lever is called force multiplier? Class 1, class 2, class 3 or class 4? Let us see the solution. When the effort arm is longer than the load arm, the mechanical advantage and the velocity ratio of class 1 lever are greater than 1. Such a lever serves as a force multiplier. That is, it enables us to overcome a large resistive force, that is load, by a small effort. So what is the correct answer? The correct answer is class 1. Let's have a look at the fifth MCQ. It says, what is the part of spectrum beyond the red and the violet extremes called? The figure is also given to us and the four options are visible spectrum, invisible spectrum, gamma rays, infrared radiations. Let us see the solution. So the part of the spectrum beyond the red and the violet extremes is called the invisible spectrum. So what is the correct answer? The correct answer is option B, that is invisible spectrum. Let us now have a look at the next MCQ. It says, what is the critical angle for glass-air interface? 22 degrees, 33 degrees, 42 degrees or 50 degrees. Four options are given to us. Let us see the solution. So for the glass interface, the critical angle is about 42 degrees. So option C is the correct option. Let's have a look at the new MCQ, that is your MCQ number 7. For the object placed between the focus and center of curvature of a convex lens, the image is, so what type of image is formed? Real and enlarged, real and diminished, virtual and enlarged or virtual and diminished? Let us see the solution. For the object placed between the focus and center of curvature of a convex lens, the image is real and enlarged. So have a look at this. This is how the figure looks like, real and enlarged. So option A is the correct option, that is real and enlarged. Let's have a look at the 8th MCQ here, which is an assertion and reasoning based question. It says, The assertion A says ultraviolet radiation from the sun is used to produce vitamin D in plants and animals. The reason is it triggers a photochemical reaction that converts sterol into vitamin D. So the four options are both A and R are true, A is true but R is false, A is false but R is true, and both A and R are false. Sunlight is composed of about 1500 wavelengths, but the only wavelength that makes your body produce vitamin D are UV rays when they hit exposed skin. Also, UV rays produce vitamin D in the plants. And ultraviolet B, that is UVB radiations from the sun, is used to produce vitamin D in plants and animals because it triggers a photochemical reaction that converts sterols into vitamin D. So what is the right answer? Both the statements given here are true, that is assertion is true and reason is also true. Let's have a look at the ninth MCQ. Two sounds of different loudness and same pitch, do they differ in their amplitudes or frequencies or waveforms or phase? Let us see the solution. So loudness is determined by the amplitude of the sound. So two sounds of different loudness and same pitch differ in their amplitudes. So what is the right option? Option A is the right option, that is amplitudes. Let's have a look at the 10th MCQ now. It says, which of the following graph is the ohmic resistors? Option A, option B, option C, and both A and B. So if you see, there are four options given. In the first three options we have the graph, and option D says both A and B are correct. Okay, so let us see the solution. So we know that the conductors which obey the Ohm's law are called the ohmic resistors or linear resistance. A graph is plotted for V against I. By taking V on the y-axis and current I on the x-axis, which is found to be a straight line as shown in both A and B. So this verifies the Ohm's law. So here both the options A and B are correct because both of them are dealing with voltage and current and they are linear graphs. Option D is the correct option. Let's have a look at the next MCQ. It says, which of the following principles on which fuse works? A is electric effect of current, B is magnetic effect of current, C is heating effect of current, and D is sound effect of current. What is the solution to this? A fuse works on the heating effect of current. So which option is correct? Option C is the correct option. Let's have a look at the next question. It says, on increasing the current in a wire, the magnetic field produced by it gets reversed in direction, increases in strength, decreases in strength, or remains unchanged in strength and direction. Let us see the solution. On increasing the current in a wire, the magnetic field produced by it increases in strength. So what is the correct option? Option B is the correct option, that is, it increases in strength. Let's have a look at the 13th question. 1 calorie is the quantity of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius, 10 degrees Celsius, 5 degrees Celsius, or 100 degrees Celsius. So we know that 1 calorie is the quantity of heat energy required to raise the temperature of 1 gram of water through 1 degree Celsius. So option A is the correct option. Let's have a look at the 14th MCQ now. It says, which quantity determines the direction of flow of heat? Option A, temperature. Option B is heat. Option C is heat capacity. And option D is specific heat capacity. So the solution says temperature determines the direction of flow of heat. So what's the right answer? The right answer is temperature. Let's have a look at the 15th MCQ now. When a radioactive uranium nucleus U emits an alpha particle, how many protons and neutrons are left in the nucleus after an alpha emission? So 93 protons and 146 neutrons, or 90 protons and 144 neutrons, 93 protons and 142 neutrons, or 92 protons and 144 neutrons. Let us see the solution. So when a radioactive uranium nucleus emits an alpha particle, 90 and 144 of protons and neutrons are left in the nucleus after an alpha emission respectively. So protons 90, neutrons 144, option B is the correct option. So let's see fill in the blanks now. That is your section A, question number 2. It begins now, and please make a note, all the questions here are compulsory. So the first question says, a dash, which is the load or effort, is the resistive or opposing force to be overcome by a machine. So this is the 1 marker, and what is the answer to this? The answer is the resistive or opposing force to overcome by a machine is called as the load. So the answer is load. Let's have a look at the second question. It says, the point at which the energy is supplied to a machine by applying the effort is called the effort point or the load point. So we have to choose correctly. This is again 1 marker. So the point at which energy is supplied to machine by applying the effort is called as the effort point. Let's have a look at the third question now. It says, a point double the height from where it was initially, then the potential energy of the body is doubled, becomes 4 times, becomes 8 times the initial potential energy. So what is the answer to this? The initial potential energy of the body is given by mgh. So at double the height, we can say that the final potential energy is mg times 2h, that is 2 times mgh, which is 2 times the initial potential energy. So what is happening? The potential energy is getting doubled. So we can say that at a point double the height from where it was initially, then the potential energy of the body is doubled. So here we have the next question. 1 horsepower is equal to 1000, 500 or 746. So we know that 1 horsepower is equal to 746 watts. That is the relation between 1 horsepower and watt. Let's have a look at the new question. It says, the resistance of conductor increases or decreases with an increase or decrease in temperature. So this question is asked for 2 marks. Let us see the solution. So the resistance of a conductor increases with increase in the temperature. So let's have a look at the next question. It says, draw a graph representing conversion of mechanical energy in motion under gravity. So here is the graph. You can see on the graph we have the x-axis, we have the y-axis. On the x-axis we have the height above the ground, and on the y-axis we have the energy. So this graph represents the conversion of mechanical energy in motion under gravity. Please make a note of this. The third question says, explain how distance from the source affect loudness of sound. So loudness, as we know, varies inversely as the square of distance from the source. If the listener is close to the source of the sound, he hears it quite louder, but if he is far away, the sound becomes feeble. That is, if he moves further away from the source, a stage may reach when the sound becomes inaudible. So we can say that closer the source, louder is the sound. So this is the explanation for how distance from source affects loudness of sound. Let's have a look at the new question now. We are dealing with question 3 of section A. So here is the first question. For the image formed by a concave lens when object is at infinity, give the characteristic of the image, give the location of the image. So let us talk about the first part. That is, the characteristic of the image is virtual, erect and diminished image. Let's talk about the location. The image is formed at the focus on the side of the object in front of the concave lens. So we have given the answer to both the questions. Virtual, erect, diminished image, that shows the characteristic, and image is formed at the focus on the side of the object in front of the concave lens. Let's have a look at the second question of section A, question 3. Give the working of device in the given diagram. The diagram is already given. We are supposed to give the working of the device. So have a look at this. If you see the figure, we are supposed to give the description for this. So when current in the circuit exceeds a specific value due to any reason such as the high voltage, short circuiting, etc., the temperature of the fuse wire rises to the extent that it melts. As a result, a gap is produced and the circuit breaks. Now current does not flow through the live wire and the appliance is saved. We can also call the appliance as the circuit here. Let's have a look at the third question. The next question says, what happens to the strength of an electromagnet if number of turns is increased, current is increased? This is again for 2 marks. Let's see the solution. Increasing the number of turns, the more turns of wire in the coil, the stronger the electromagnet. As the number of turns increases, the electromagnet gets stronger. What happens when current is increased? The more current flows through the coil, the stronger the electromagnet. That means with the increase in current, the electromagnet gets stronger. Let's have a look at the fourth question. It says, calculate the heat energy required to raise the temperature of 4 kg of water from 20 degrees Celsius to 50 degrees Celsius. Specific heat capacity of water is 4200 joule per kilogram per Kelvin. So let us see the solution. It is given that the mass is 4 kilogram and then the specific heat capacity of the water is given 4200 joules per kilogram per Kelvin. So the change in temperature is 50 minus 20, which is 30 degrees Celsius, and then as we know, the heat energy Q is given by the change in temperature multiplied by mass multiplied by the heat capacity. So 4 multiplied by 4200 multiplied by 30, that is the heat energy, which is 5,04,000 joules. Let's have a look at the new question. It says, what is the nature of the current produced by an AC generator? The second question says, what does the term alternating mean in alternating current? Let us see the solution. The current produced by an AC generator is alternating current AC, which means the current periodically reverses its direction. Alternating refers to the current that changes both its magnitude and direction periodically. Here we have the new question. Answer the following question. What is gamma radiation? State any 2 properties of gamma radiation. So gamma radiation is a high energy electromagnetic wave emitted from the nucleus of an atom during radioactive decay. Unlike alpha and beta radiations, gamma radiation has no charge and no mass as it consists of photons. It often accompanies alpha or beta decay to release excess energy from the nucleus. So that answers your first part. The second part is properties of gamma radiation. So gamma radiation has high penetrating power and can pass through several centimeters of lead or meters of concrete. It is not deflected by electric or magnetic fields due to its neutral nature. So the next question says, the following diagram shows the process of nuclear fission. Here it is. We are supposed to answer three questions. Identify the particles X and Y in the diagram. Explain the role of neutrons in the chain reaction. And state one advantage of nuclear energy. Here is the solution. So X is the uranium, that is 235 nucleus, and Y is the neutron. What is the role of neutrons? A neutron collides with uranium-235 nucleus, causing it to split into smaller nuclei and release more neutrons. The second rule says the released neutrons further collide with other uranium nuclei, continuing the chain reaction. Let us talk about the advantage of nuclear energy. It produces a large amount of energy with a small amount of fuel. Now we are dealing with section B, and this is question number 4. Here we are supposed to attempt any 4 questions from this section that carries 10 marks. So the first question is, answer the following questions. An object is placed 12 cm from a convex lens of focal length 8 cm. Here is the figure. Find the image position. Find the nature of the image. So the formula for lens is 1 by f is equal to 1 by v minus 1 by u. So here f is 8 and u is minus 12. So once you solve this further, you get the value of v as 24 centimeters. Now locate it 24 centimeters from the pole of the mirror behind the mirror. That is the position, and the image is real and inverted. Let's have a look at the next question of section B. The second question. Answer the following question. State the laws of refraction and define refractive index. This carries 3 marks. So let's talk about the laws of refraction. The incident ray, refracted ray and normal lie in the same plane. Sin I by sin R is equal to n, where n is the refractive index. Let's talk about the refractive index. It's a ratio of the speed of light in a vacuum to that in the medium. The next question says, answer the following question. 3 questions are given. Define the angle of deviation in the context of light passing through a prism. Second says, draw a diagram showing the passage of light through a triangular prism and mark the angle of deviation. Third, what happens to the angle of deviation as the angle of incidence increases from a very small value? This question is asked for 4 marks. Let us see the definition. The angle of deviation is the angle between the direction of the incident ray and the direction of the emergent ray when the light passes through a prism. The diagram. Here it is. Let us talk about the behavior of deviation. Initially, the angle of deviation decreases as the angle of incidence increases. At a particular angle of incidence, the angle of deviation becomes minimum, that is minimum deviation angle. Beyond this point, the angle of deviation increases with further increase in the angle of incidence. Let's talk about the next question. It says, draw a neat labeled ray diagram to show the formation of image by magnifying glass. State 3 characteristics of the image. The question is asked for 3 marks. So let the object AB be situated between focal length and optical center of a convex lens, then its image A'(B' will form on the same side of lens. The image so formed will be virtual, magnified and erect. Consider the diagram for few minutes. Let's have a look at the next question. It says answer the following question. The figure given below shows the light blue plus red plus green, three colors, incident on a prism and on a parallel sided glass slab. Complete the diagrams by drawing the refracted and the emergent rays. This question is asked for 3 marks. Consider the ray diagram for few minutes. So in a prism, the refraction takes place at two inclined surfaces. So the prism causes dispersion and deviation of light into its constituent colors and a spectrum is seen. In case of the parallel sided glass slab, the refraction takes place at two parallel surfaces. On the first surface, the colors are separated due to different deviation from the rays of different colors. That is, dispersion takes place. On the second surface, the ray of each color is refracted such that the emergent ray is parallel to the incident ray on the first surface. Since there is no further separation of colors due to refraction at the second surface, so the emergent colored rays are parallel to each other and they are close that it is difficult to see the separate colors. Let us see the next question. It says draw a ray diagram to show the appearance of a stick partially immersed in water. Explain your answer. This question is asked for 4 marks. A stick partially immersed in water in a glass container appears bent or raised as shown in the figure below. So here is the figure. This happens because the rays appear to come from P, which is the virtual image of tip P dash of stick, due to the refraction from denser medium, that is water, to the rarer medium, air, at the surface separating two media. Let's have a look at the next question. It says answer the following question. State the principle of moments. Explain its application in the working of a seesaw. A uniform beam of length 6 meter and weight 100 Newton is balanced at a point 2 meter from one end. What is the moment of the beam about the point of support? This question is asked for 3 marks. Let's see the solution. The principle of moments state that for a body to be in equilibrium, the sum of clockwise moments about a pivot must equal the sum of anti-clockwise moments. On a seesaw, children sit at varied distances from the pivot to balance their weights, ensuring equilibrium. When two children sit at different distances from the pivot, that is fulcrum, the heavier child must sit closer to the pivot to balance the seesaw. The weight, that is force, is multiplied by the distance from the pivot, which is the moment arm, determines the balance. If the moments on both sides are equal, the seesaw remains horizontal. The moment is calculated using the following formula. That is, moment is equal to force multiplied by perpendicular distance from the pivot. The weight of the beam acts as its center of gravity, which is at the midpoint of the beam, 3 meter from either end. The pivot point is 2 meter from one end, so the distance between the center of gravity and the pivot is 3 meter minus 2 meter, which is 1 meter. Thus, the moment is equal to 100 newtons multiplied by 1, that is 100 newton meter. The moment of the beam is about the support is 100 newton meter. Let's have a look at the new question now. It says answer the following question. Define work done. A force of 20 Newton is applied to move a box at a distance of 5 meter in the direction of the force. Calculate the work done. A person pushes a box with a force of 50 Newton, but the box does not move. What is the work done by the person in this case? The figure is given to us. This question is asked for 3 marks. So the work done is defined as the force applied on an object multiplied by the displacement of the object in the direction of the applied force. Mathematically, work done is given by force times displacement times cos theta, where theta is the angle between the direction of the force and the displacement. If the force and displacement are in the same direction, cos theta is equal to 1, that is theta is 0 degrees. Part B, force is given 20 newtons, displacement is 5 newtons. Since the force and displacement are in the same direction, cos theta is 1. Using the formula, work done is given by force into displacement, that is 20 multiplied by 5. 20 newtons multiplied by 5 meters, that is 100 joules. So the work done is 100 joules. Third part, force is 50 newtons, displacement is 0 meters. So using the formula for work done is force multiplied by displacement, that is 50 newton multiplied by 0 meters, that gives me 0 joules. So the work done is 0 joules. Let's have a look at the new question now. It says, answer the following question. What is the SI unit of kinetic energy? Second, a ball of mass 500 gram is thrown vertically upward with a velocity of 10 meter per second. Calculate its kinetic energy. Third, at the highest point of its motion, what happens to the kinetic energy of the ball? This question is asked for 4 marks. Here is the solution. The SI unit of kinetic energy is joule. For part B, it is given that the mass is 500 grams, which is 0.5 kgs, and the velocity is 10 meters per second. Using the formula, kinetic energy is half mv square. That gives me half multiplied by 0.5 multiplied by 10 square. That is 0.25 multiplied by 100, that is 25 joules. Answer to the third part, at the highest point of its motion, the velocity of the ball becomes 0. Since kinetic energy depends on velocity, that is kinetic energy is half mv square, the kinetic energy at the highest point becomes 0. Let's move on to the next question, that is your section B, question number 7, and the first question of that. Answer the following question. What is a simple machine? And give 2 examples of simple machine. This question is asked for 3 marks. A simple machine is a mechanical device that changes the direction or magnitude of a force to perform work efficiently. It reduces effort but cannot reduce the total work done. Part B, the examples are a lever, a crossbar used to lift heavy objects. Inclined plane, a ramp used to move objects to a higher level with less effort. Simple machines work on the principle of conversion of energy, where the product of effort and distance equals the product of load and distance. Let's see the next question of section B, question number 7, that is the second question. Answer the following question. Define transverse and longitudinal waves. Give 1 example each. In which type of wave do particles oscillate perpendicular to the direction of wave propagation? Explain briefly. Third, why can transverse waves not propagate in gases and liquids? This question is asked for 3 marks. Let's focus on the first part. Transverse wave, a wave in which particles of medium oscillate perpendicular to the direction of wave propagation. Example, light waves or water surface waves. Longitudinal wave, a wave in which particles of the medium oscillate parallel to the direction of wave propagation. Example, sound waves or waves in a spring. Let's talk about transverse waves. In this wave, the particle vibrate perpendicular to the direction of energy transfer. Example, in water surface waves, particles move up and down while the waves move horizontally. Third, transverse waves require a medium with shear elasticity for oscillation. Liquids and gases lack this property as their molecules cannot sustain shear stress, hence transverse waves cannot propagate through them. Let's have a look at the new question of section B, question number 7, that is the third question. Answer the following question. Wave A and wave B are given to us. Which wave, A or B, has a higher frequency? How is frequency related to the pitch of the sound? If the frequency of wave B is 2000 Hz, calculate the period of the wave. This question is asked for 4 marks. Let us see the first part. So wave A has higher frequency because it has more cycles, that is more waves in the same time interval compared to wave B. Part B. The frequency of a sound wave determines its pitch. A higher frequency corresponds to a higher pitch and a lower frequency corresponds to a lower pitch. The time period T is given by the formula T is equal to 1 by F. That is 1 by frequency, which is 1 by 200, that is 0.005 seconds. Let's see a new question now. This is section B, question 8. The first question says, examine the diagram showing 3 different materials A, B and C used for wires with identical dimensions. The materials have resistivities rho A, rho B and rho C. Consider the diagram for few minutes. A, B, C. This is given. The first question says, which material offers the least resistance and why? So if the 3 resistances A, B and C are A, RB and RC respectively, arrange them in increasing order. What property of a material affects its resistivity? Here is a solution. Material A offers the least resistance because its resistivity is the smallest. Option B. Since R is equal to rho times L by A and the dimensions are identical, so we can say that the resistivity of A is less than the resistivity of B is less than the resistivity of C. Third one, the property of a material that affects its resistivity includes the type of material, temperature and electron density. Let's have a look at the new question. It says, answer the following question. What is nuclear fission? Explain with one example. This question is asked for 3 marks. So nuclear fission is the splitting of a heavy nucleus into 2 lighter nuclei, releasing a large amount of energy. For example, when uranium-235 absorbs a neutron, it splits into barium-139, krypton-94 and 3 neutrons releasing energy. This process is used in nuclear reactors to generate electricity. The released neutrons sustain a chain reaction, making fission a powerful energy source. Let's have a look at the new question now. Here we have it, that is question 8 of section B. It says, answer the following question. A conductor of resistance 4 ohm is connected in series with 6 ohm resistor. If a current of 2 ampere flows through the circuit, calculate the potential difference across the entire circuit. Calculate the potential difference of each resistor. This is for 4 marks. So the total resistance in the circuit is 4 ohms plus 6 ohms, that is 10 ohms. Using Ohm's law, we have V is equal to I multiplied by R. So the total potential difference across the circuit will be V is equal to 2 ampere multiplied by 10 ohm, that is 20 volts. Second part, now the potential difference across the resistor is 4 ohms. So V1 is equal to 2 ampere multiplied by 4 ohms, that is 8 volts. And across 6 ohms, we have V2 is equal to 2 multiplied by 6, which is 12 volts. So the total potential difference is 20 volts with 8 volts across the 4 ohm resistor and 12 volt across the 6 ohm resistor. Now we are dealing with section B, question number 9, and here is the first question. What is the difference between heat and temperature? So what is heat? It is the total energy transferred between objects due to a temperature difference. It is a form of energy measured in joules. What is temperature? It measures the average kinetic energy of a particle in a substance. It indicates how hot or cold an object is, measured in degrees Celsius or kelvins. For example, a cup of boiling water and a swimming pool at 30 degrees Celsius have different heat content, even though the pool's temperature is lower, as it contains more water and thus more heat energy. Let's have a look at the next question. It says, answer the following question. A metal block of mass 200 gram is heated to 100 degrees Celsius and dropped into 400 gram of water at 20 degrees Celsius after thermal equilibrium is reached. This is for 3 marks. The question says, 2 questions. What will happen to the final temperature of block and water? The second one is, and if the final temperature is 30 degrees Celsius, calculate the specific heat capacity of the metal. So the answer to the first part is, as water will gain heat and its temperature will rise, block will lose heat and its temperature will decrease. And at last both will have the same temperature. Second part, using the principle of calorimetry, the heat lost by the metal block equals the heat gained by the water. So heat lost by metal, that is given by M multiplied by C multiplied by the difference between the initial and the final temperature of the metal. So the heat lost by metal is 0.2 multiplied by C multiplied by 100 minus 30, which is 70. That is the heat gained by water, right? So that further gives you, after solving, 16.8 joules. Now since the heat lost by the metal equals heat gained by the water, we can equate this now with 16.8 to get the final answer as 1.2, and here we can say that the specific heat capacity of the metal is 1.2 joules per gram per degree Celsius. Let's have a look at the next question, the third question. It says, answer the following question. Consider the diagram for few minutes. This question is for 4 marks. The first part says, what is the principle of operation of a transformer? The second part, a transformer is used to step up the voltage from 110 volts to 220 volts. If the primary coil has 150 turns, how many turns does the secondary coil have? The third part says, what are the losses in a transformer? So the answer to the first question says, let's talk about principle of operation of a transformer. The transformer operates on the principle of electromagnetic induction. When an alternating current flows through the primary coil, it produces a time-varying magnetic flux. This magnetic flux includes a voltage in the secondary coil according to the Faraday's law of induction. The transformer works efficiently only with alternating current, that is AC, as it requires a varying magnetic field to induce voltage in the secondary coil. Second part, calculation of the number of turns in the secondary coil. We'll use the formula for the transformer, that is V1 by V2 is equal to N1 by N2. We're already given with the value of V1 110, V2 is 220, N1 is 150. We can easily find out N2 by substituting the values. 110 by 220 is equal to 150 by N2. Simplifying this further, 1 by 2 is equal to 150 by N2. N2 is equal to 150 multiplied by 2, that is 300. So we can say that the secondary coil has 300 turns. Let's see the third part, that is the losses in the transformer. There are mainly 2 types of losses in a transformer. The core loss or the iron loss. These losses occur due to the magnetization and demagnetization of the core material. They include hysteresis loss and eddy current loss. Copper loss. These losses occur due to the resistance of the wires in the coils. The current flowing through the coil causes heat due to resistance, leading to energy loss. So that's it for the sample paper. This sample paper we have solved for Physics 2025. Keep learning with top scholars. See you children and all the best.